Good afternoon. Today we will start solutions. My dear students, in our daily life, we rarely come across pure substances. Pure substances means which is made up of only one kind of particles. Just a minute. Okay. So, most of these are homogeneous mixture. So, homogeneous mixture means homo means same, which means it has same composition and same appearance. So, in our daily life, we come across generally with homogeneous mixture. So, these generally constitute the solution. So, first, we should know what is solution. A solution is a homogeneous mixture. Homogeneous mixture of two or more chemically non-reacting components. What is solution? A solution is it means it is a homogeneous mixture. Homogeneous mixture which means whenever the solution is formed, it has same composition and same appearance of two or more, minimum of two components or more than two chemically non-reacting components. Okay, so solution is a homogeneous mixture, which means whenever the solution is formed, the composition and appearance of all the solution component is same. For example, I am taking one glass of water and adding sugar in it, salt in it, and lemon in it, and making a lemonade. Whenever the lemonade is formed, its composition is same throughout the beaker, okay, or glass. Whether you are seeing it from the top or from the below, its composition is same and its also appearance is same. So now, components of solution. Components of solution. Components of solution. My dear, there are two components, solute and solvent. Solute, which is generally present in the less amount. Which is generally present in less amount by mass. And solvent, which is present in more amount. Suppose I am taking 1 glass of water and adding 1 spoon of sugar in it. So your 1 glass of water is your solvent and a small amount of sugar is your solute. Or you can say that solvent is that component which determines the phase of the solution. That whenever the solution is formed, what is the phase of that solution? Either it is solid, either it is liquid, or either it is viscous, or either it is gas. So solute is that component which is generally present in less amount, and solvent is that component which is present in more amount. Is there any doubt till now? Please let me know. Types of solution. See, there are so many types. First is on the basis of nature of solvent. Suppose your solvent is water, then it is your aqueous solution. Aqueous solution is that in which solvent is water. Okay? And second is your non-aqueous. Non-aqueous means, which means in which solvent is other than water, like benzene, carbon tetrachloride, etc., or acetone, whatsoever. So, if your solvent is water, then it is aqueous solution. And if it is other than water, then it is your non-aqueous solution. Next, types of solution on the basis of amount of solute. According to this, it is concentrated and dilute. Dilute where the amount of solute is less and amount of solvent is more. And concentrated means here the amount of solute and solvent are almost comparable. Suppose I am taking 1 glass of water and I am adding around, around you can say that 200 gram of sugar in it, or 100 gram of sugar in it. Okay, and say I am taking for dilute 1 glass of water and a pinch of salt. Here the amount of solvent is more, here it is less. Here students, element of solution can be 2 or more than 2. But at the 12th level, we will be dealing with binary solutions only. Binary means 2, in which one component is solute and another component is solvent. Okay? Up to 12th level, we are dealing with binary solutions in which one component of is solute and another one is solvent. Till now, is there any doubt? Please let me know. Okay? So, solute, solvent. According to this, there are 9 types of solution. In first case, your solvent is solid, solid, solid. In 4 to 6, the solvent is liquid. Last 3, your solvent is gas. So, in this case, solid, liquid, gas. Solid, liquid, gas. Solid, liquid, gas. So, how you will get the question from this area? Examiner can ask, give one example of solid solution. Solid solution. These are the examples of solid solution. So first is your solid in solid. It means your solute is also solid and your solvent is also solid. Can anybody in the classroom give me any example? Anybody in the class? Do you have any idea? Where both the solute in solvent and solid? But the alloys. It is a homogeneous mixture of metal with metal or metal with non-metal. Okay? So alloys are the common example. Or gold. Not pure gold. Like pure gold is 24 karat. But if I am using it for making jewelry, then it is generally 18 karat. It is a mixture of pure gold with silver. So it means 18 parts is your gold and rest other part is your 6 part is your silver. So it is also a mixture of solid in solid solution. The first one example is your solid and solid solution is your example is all. That is your 22 karat gold, 18 karat gold, all your alloys. Next is your liquid in solid. It means there your solute is liquid state and your solvent is in your solid state. But you know about the hydrated salts in which some water of crystallizations are present. It is your either copper sulfate pentahydrate or magnesium sulfate heptahydrate. It is an example of liquid in solid solution. Third is your gas in solid solution. It means here the solute is gas and solvent is solid. Like your hydrogen gas in palladium. Hydrogen gas in palladium. It is solid, it is a gaseous state. Now, talking about liquid solutions. First is your solid in liquid. It is very common example. NaCl in water, sugar in water. Okay. Next one is your liquid in liquid. Like your acetone in water, alcohol in water, either ethanol, methanol. They both are present in liquid state. From this, you will get the question like this. Give an example of liquid in liquid solution. In your exams, you will get the question like this. Okay? In 1 mark. Now, next is your gas in liquid state, where your solute is gas and solvent is liquid. Its common example is your cold drinks. Cold drinks. There, solvent is liquid and CO2 gas is your solute. Okay? Next is your solid in gas state. It is your camphor, kapoor in nitrogen gas. Camphor in nitrogen gas. Next is your liquid in gaseous phase. It is your moisture in air or humidity in air. Okay. Last is your gas in gas. It is your air, which is a homogeneous mixture of different gases. Okay. Till now, is there any doubt? Please let me know. Concentration means amount of solute present in a given amount of solution. how much solute is present in a particular amount of solution. Suppose I am adding 1 gram of sugar to 1 glass of water. So it is the amount of solute present in a given amount of solution. Okay. So there are so many terms which are used to express the concentration, like percentage, molarity, molality, normality, strength, mole fraction, mass fraction, parts per million, parts per billion, and we will discuss one by one. Okay? First, I am taking percentage. First concentration term is percentage. Percentage means, what do you mean by the term percentage? That is your mass of component over total mass. It is percentage, which means it should be multiplied by 100. Okay? It can be expressed like M by M, V by V, or M by V. In some books, you will get W by W, V by V, or W by V. So, first M by M. M by M means mass percentage of a component, which means mass of that component divided by total mass of all the components into 100. Simple. Next is your V by V. V means volume, and volume is for liquids. So here, volume of a particular component divided by total volume of all the components into 100. Because VA, one component and total component are 2 into 100. Next is M by V, mass of a particular component divided by volume of a particular, all the components in ml into 100. Okay, simple it is. First one is your mass percentage or volume percentage, or mass by volume percentage. M by M, V by V, and M by V. It is the first way of expressing the concentration of a particular solution. Second is your molarity. Second is your molarity. Molarity represented by capital M. It is equal to number of moles of solute dissolved per liter of solution. Number of moles of solute dissolved per liter of solution. It is represented by, mathematically it is M is equal to N by V. What is M? M here it is molarity. N is number of moles, which can be written as given mass over molar mass. It is given mass over molar mass into volume. If it is in ml, then it should be converted per liter into liter. So it should be divided by 1000. It goes up. Mathematically, molarity is your. I will discuss numericals on it also. First, I am telling you the definitions. Okay. Its units are either molar or moles per liter. Okay. Molar. Here R is there. Then another term is also molality. Okay. Molarity is number of moles of solute dissolved per liter of solution, which means in 1 liter or per liter, how many number of moles of a particular solute are present. It is your molarity. Fine, it is represented by capital M. Next term, similar to that term is your molality. Generally, the students get confused between these two terms. And you see only one word difference. That was molarity. It is your molality. It is represented by small m. It is also number of moles of solute present per kg mass of solvent. See here it was, in case of molarity, it was number of moles of solute present per liter of solution. Okay. Here it is number of moles of solute present per kg mass of solvent. In this, no volume is included. That's why it is the best way of expressing the concentration of a particular solution. Why? Because it is temperature independent. It does not include volume. Okay. So it is M is equal to given mass over molar mass into mass of solvent. If mass of solvent is in grams, then it should be converted into kg. Okay. Till now, is there any doubt? Please let me know. Strength. Next is your strength. Almost strength and molarity are related. Strength is the amount of solute in grams. I repeat, here the solute should be in grams present per liter of the solution. Okay. Here, amount of solute in grams present per liter of the solution. So strength of a solution, units are gram per liter, solute in grams or mass of solute in grams over volume in liters. Okay. So mass of solute in grams present per liter of solution. Now, normality I will discuss in the next class. I am taking another term, that is your mole fraction. It is represented by X, mole fraction. It means, suppose there are two components in a solution. One is solute and another one is solvent. And you have to calculate the number of mole fraction of both the components. So mole fraction is defined as the number of moles of that component divided by total number of moles of all the components. Number of moles of that particular component divided by number of moles of all the components. Similar for B, it is and sum of the mole fraction of all the components is always equal to 1. If in a solution, if there are two components, like in case of binary solution, if you are calculated the component mole fraction of one component, you can easily calculate it the another one. Suppose x say here is equal to 1 minus x. Okay. Now next is yours. Parts per million. Parts per million. Million means 10 raised to power 6, which means the mass of solute present in 1 million parts by mass of solution. Suppose I am calculating the ppm for component A, it is equal to parts per million of A component is equal to mass of A over total mass of solution into 10 raised to power 6. So it is defined as the mass of the solute presenting 1 million part of mass of a solution. Okay, my dear students, I hope it is clear to you all. In today's lecture, we have started second chapter, that is solution. What is solution? Solution is a homogeneous mixture of two or more chemically non-reacting components. Okay, and up to 12th standard, we have to study only binary solutions, which means it includes two components. One component is solute, which is generally present in less amount, and another is solvent, which is generally present in more amount or actually describes the phase of the solution. Phase means the final solution will be solid, liquid, or gas. After that, we have discussed the type of solution on different bases. Like on one basis, aqueous and non-aqueous. Aqueous means the solvent is water. Non-aqueous means it is other than water, like benzene, carbon tetrachloride, etc. etc. Next is on the basis of nature of solute, amount of solute, concentrated and dilute. Dilute means the amount of solvent is more. And concentrated means the amount of solvent is less. After that, we made one table where we have discussed the type of solution on the basis of physical state of the solvent. Okay, like solid in solid, solid in liquid, solid in gas, etc. After that, we have discussed different concentration terms like percentage. Percentage means M by M, V by V, or M by V. Then strength, molality, and mass mole fraction, parts per million. Okay. Till now, is there any doubt? Please let me know.